and Q are the lengths of the perpendiculars from the origin to the lines. So these are the two lines. X cos theta minus y sin theta is equals to K cos 2 theta. The question is K 2 theta. And X sec theta plus Y cos sec theta is equals to K respectively. Prove that this. Everyone, please understand the question using the XY plane. So I'm using the XY plane. So this is the Y axis we have. And this is the X axis, right? Now, this is the point of origin. Now, what they are saying, if P and Q are the lengths of the perpendiculars from the origin. So let's make the lines first. So let's say this is the line L1 and let's say this is the line L2 we have, right? So if I will draw the perpendicular from here like this, right? And if I will draw the perpendicular from the origin on line L2. So let's say this is line L1, this is line L2. This equation is for line L1 and this equation we have for line L2, right? Perpendicular length of the perpendicular is P. So for this one, I am taking this length as P and for this one, I am taking this length as Q. Now, whenever we have a perpendicular on the line, directly we have the formula, the distance formula from some point or origin. So D is equals to A of X1 plus BY1 plus C over the square root of A square plus B square. This is the direct distance formula of the perpendicular on the line. Now, everyone, I will apply this formula for line L1, then I will apply this for L2. So let's talk about L1. So in this formula, this A, B, C, I will get from the equation on which the perpendicular falls. So if you will see this perpendicular, this falls on line L1. So A, B, C, I will get from the first equation. If you will see, when we apply for the line 2, we'll do the same formula. So from there, L, A, B, C, I will get from line L2. Okay, let's do that. So I will apply for the line L1. Right? So distance of perpendicular is P. So that is small p, that is equals to modulus of. Now, what is A? A, whatever you have in multiply with X in the equation, that is cos theta. So it's cos theta times X1 plus B. B is minus sin theta with Y. So minus sin theta multiply Y1 and C, you have to take it to the left hand side. So it will be negative K cos 2 theta. Okay, because we have to take it to the left side. Divided by square root of A square. A is cos square theta. And plus the B square, which is minus sin theta whole square, which is sin square theta only. Now you know that cos square theta plus sin square theta is 1. Correct? So you are left with numerator only. Now, everyone, what is this X1, Y1? You will always get from a point which is on the perpendicular. So on the perpendicular, if you will see this point, because perpendicular start from origin. So this point is 0, 0. This is the point. If it is origin, then what's the matter? No problem at all. This is the point. So 0, 0. So X1, Y1, I'll get from the perpendicular. So this is 0. This complete will be 0. Then you are left with P is equals to minus of K cos 2 K minus K cos 2 theta because numerator is 1. Now, when I open the modulus, it will give me a positive value. So P is equals to K cos 2 theta. Right? Now, everyone, let's apply the same formula for line 2. So distance is what? Q. This we have is equals to modulus of A. So A is multiply with X, that is sec theta, multiply X1 plus Y. B is cosec theta into Y1 minus, you have to take this K to the left hand side divided by this, and the square root of secant square theta plus cos secant square theta because A is sec and B is cosec. Now, when I open this, I know that X1, Y1 because this also starts from the origin only. So 0, 0. So this is 0, this is 0. So you are only left with negative K over, I am just changing it. It will be 1 over cos theta, cosec square, cos square theta. And this will be 1 over sin square theta because we know that sec theta is 1 over cos and sin, cosec is 1 over sin. So when I solve it further, it gives me negative K over, when I take the LCM here, it will become sin square theta and cos square theta. So cos square theta, wait a minute, let me write it nicely. Plus sin square theta over cos square theta, sin square theta. This will give you 1. So you are left with negative K over 1 over. When you are left with 1 over cos square theta and sin square theta with the square root. Now when this cos square theta, sin square theta, both are in multiply, come out of the square root, it will become cos theta and sin theta. So this will go above, and when negative sign come out of the moderate, become positive. So you are left with this k multiply cos theta sin theta. So this is the value of q. So I'm just removing it because this is not required now. I got the value of q. So this is q actually. Now we have to prove this one, right? Now what I am taking the left hand side. So what is the value of p? P is k cos 2 theta square 4 multiply q square. So it will be k cos theta sin theta whole square. So it will be k square cos square 2 theta plus 4 multiply k square cos square theta sin square theta. K square cos square 2 theta. You know that if I will take this 4 cos square theta sin square theta, this is an identity. What is the identity? We know that sin square theta is equals to 2 sin theta cos theta. This is an identity. When I do the square of this, so I'm getting the square of this also, which is 4 times sin square theta cos square theta. So I'm directly taking it as sin square 2 theta, correct? So it will be k square cos square 2 theta plus k square sin square 2 theta, right? When I take k square common, so you are only left with cos square 2 theta plus sin square 2 theta, which is equals to 1, which is an identity, right? So 1 into k square is k square. So we have proved it equals to right hand side. So that's it, everyone. So yeah, thank you. Thank you so much. This is k, right? We took the k square common and it will become cos square 2 theta plus sin square 2 theta. Angle could be anything, but you know that cos square theta plus sin square theta is equals to 1, right? So yeah.